Hello again, AP Physics 1. I'm so glad you joined me for practice set D. Today, we're going to be talking about perfectly inelastic, okay? So, let's say I'm an archer. I take out my bow, okay? So I have my bow here, I'm pulling back, all right, and I'm gonna fire, okay? Let's say this arrow strikes a small target, hits it. What's going to happen as it strikes that target and gets stuck in it? Yeah, the whole thing's going to move forward, right? What do you notice? It hits the target and ends up like stuck to the target. Those two things are stuck together. So what perfectly inelastic means is that after a collision, the two objects are stuck together. Okay? So these two objects are now one object. So I've kind of taken two objects and now they're just one object. Okay? So that's what perfectly inelastic. The reason I say perfectly is that I end with truly only one object. If some piece flies off, it's not perfectly. It's close, but not perfectly. Right? Okay? So perfectly inelastic means that the objects are stuck together at the end of my collision. Okay? So, one way to help remember is that this arrow ended up inside the box, the target. Okay? So perfectly inelastic means in one object ends up inside of the other object. Okay? So one object is inside, they become one thing. Okay? So how does this look mathematically? How do we picture this? Well, I have my two normal objects, so MVI plus MVI, right? So that part is pretty normal, but then something interesting happens. I now have one object, right? So instead of saying MVF plus MVF, I can just say M plus M, and I know they both have the same final velocity, right? Because they're one thing now. They're treated as one object, okay? Now, why do you think kinetic energy is not conserved or constant? Let's think about this. Where might we lose some energy in this collision where the objects are kind of ending up inside? Yeah, well, one will probably lose some to heat, right? Friction, because I have these objects moving past each other. But also, the shape of this object has to change, right? Maybe even the shape of this object has to change. So because of that change of shape, that takes energy, so energy will not be conserved. Okay? So I'll put change of shape. Okay? Now, let's look at our example problem. We have a 1850 kg luxury sedan stopped at a traffic light, is struck from behind by a compact car with a mass of 975 kg. The two cars become entangled. That's my key word. Entangled means they're stuck together, right? As a result of the collision, if the compact car was moving at a velocity of 22 meters per second to the north before the collision, what is the velocity after the collision? So let's go ahead and make our chart as we have before. So we got the luxury sedan, and we got the compact car. Okay, so these are my two objects. What's the mass of the luxury sedan? Yeah, so the mass is 1850 kg. What was the initial velocity of the luxury sedan? Yeah, right? Remember, the luxury sedan is, where is it? Stopped. So if it's stopped, its initial velocity is 0. Okay, what's the mass of the compact car? Yeah, it's 975 kg. Okay? What was the initial velocity of the compact car? 22 meters per second north. So let's go ahead, set up our axes. Let's do north as positive and south as negative. Okay, so we have up, positive, down, negative. Okay, and then what do I know about these two final velocities? They're the same, right? So these VF is kind of shared between those two things because I have these two objects. Stick them together, they're going to become one object. So let's go ahead and set up my equation. So I got my object 1, my luxury sedan, and, well, remember, what was our first step, right? Sum of the momentum equals sum of the momentum, right? The addition of all the momentum is equal to the addition of all the momentum. So I got something like my compact car MVI plus my luxury sedan MVI equals M plus M, right? And then I have this VF, which is the same for both, right? One object, same velocity. And remember, my luxury sedan is initially stopped, so what can I do with this whole section here? Yeah, I can just get rid of that, right? Because the velocity is 0, 0 velocity means 0 momentum. So let's go ahead and write down what we know. So we have, what's my initial mass of the compact car? 975. The velocity is times 22 equals, here I got my 975 plus my luxury sedan is 1850. And what am I trying to find? Yeah, I need to find my final velocity. So all I need to do here is just take this and divide by this. So I have 975 times 22, all divided by 975 plus 1850 is equal to my final velocity. Okay. If you want to go ahead and calculate this, you can. I'm not going to. The important thing is to know it should be less than 22, right? If something collides and they stick together, the total velocity should go down because the mass went up. Okay, let's look at our second question. Let me scroll down, give me 1 second. Okay, let's look at our second question. So, we have two carts with masses of 4 kg and 3 kg move towards each other on a frictionless track with speeds of 5 meters per second and 4 meters per second, respectively. They stick together after colliding head on. Find the final speed. So I have one cart, and I have a second cart. Okay, so my first cart would be 4. Okay, my mass is 4. And then its initial velocity is 5. Let's say cart 1 is starting over here. So cart 1 will be moving this way. So let's make this positive, this negative. So cart 1 will be moving this way, that's a positive direction. Remember, my final velocities of both are going to be the same, right? So both final velocity is the same. Now, my second cart, the mass is 3 kg. What's the initial velocity of the second cart? Yeah, that's this one here. So 4, but remember this one needs to be moving this way, right? They're headed towards each other, so this has got to be in this direction. So this is going to be a negative 4. Okay? Now, let's go ahead. First step, right? Initial equals final. Okay? Now, let's go ahead and write down our formula. So I have something like cart 1 MVI plus MVI of my second cart is equal to M plus M. And then remember, both my final velocities are the same. So something like this, right? Let's go ahead and plug in. So I have 4 times 5 plus, this will be 3 times, apologies, negative 4 equals, and I have, this is 4 plus 3 VF. So let's go ahead and simplify this. So here I will have 20 minus 12 equals 7 VF. So that should give me something like 8 equals 7 VF. Divide both sides by 7, so you get 8 7 meters per second equals VF. Which direction is this? Yeah, this should be in my right direction. Okay, based on my axes that I set here. Okay, in other words, this heavier cart that's also moving faster is going to win that collision. So you have these two objects heading towards each other. The one that wins has the greater momentum. That one has the greater momentum, right? This cart one has the greater momentum, therefore it's going to win. There's no conceptual question here. So go ahead and work on these questions, and I will see you again for set E.